paper. So when sketching graphs, you want to use inductive reasoning. What that is like you want to essentially draw conclusions based off of some information that you already have. Okay, you want to draw conclusions based off of the information that you already have. If you're not given a function, okay, then you use that information, whatever information is given to you, to draw the quadratic. First off, the graph of a quadratic looks like what?
X squared.
Like what's like, describe what it looks like. It looks like a U. It's called a parabola. So it's either going to point up or it's going to what?
Point down.
Point down. And so since you know that that's what it looks like, then you know to use the other information given to you to draw a quadratic that's either going to point up or it's going to point down. So, for example, I have sketched the graph of the parabola with a vertex at 1, 2, and a range of y is greater than or equal to 2. So since I know that I'm trying to graph this parabola, and I have a vertex at 1, 2, I can, in no equation, I can use the fact that the vertex is at +1, +2. So in my sketch, with my x-axis and my y-axis, I'm going to have a point at 1, 2 that represents my vertex. Okay? Now, knowing what I know about the vertex of a parabola, let's take these two general ones I drew up here. Where is the vertex located on either of these parabolas? At that symmetry point here, as well as here. This point right here, yes, is known as the vertex, but it's also known as a minimum. Why? Because that is the lowest value it can be. And this would be known as a what? A maximum, because that's the highest the parabola can go. So now I need to determine, is this vertex point that I have here on my sketch, is it going to be a minimum or a maximum? So I'm going to use the remaining piece of information. It says the range of this parabola is y is greater than or equal to 2. Range relates to my y's. So if y is greater than 2, is this going to be a parabola that opens up, or is it going to be a parabola that opens down? Up. And it's going to open up because, again, all of my y values should be greater than 2. So if this is 2, I don't want it to point down because then it's going to be all my y values that are less than 2. But using inductive reasoning, what I already know about quadratics and the information that they give me, I'm able to draw a sketch of this parabola. And this point right here, where my vertex is located, is that a min or is it a max?
That's the
It's a min. Okay, very good. And even though it doesn't ask this is going to be a good time for me to kind of go back over some stuff. What is the axis of symmetry? X equals 1, because remember, it is the x coordinate of your vertex. Because the graph opens up, that means that A had to be, if I knew what the equation was, A had to be what? 0.
Positive. Oh.
It had to be positive, so that means it had to be greater than 0. Now, all of that I can deduce from just this little bit of information, okay? Now, what I've done in the purple, that's extra. All I really needed to do was in the black, which was to draw the sketch. Yes. Because the parabola opens up on the actual equation for quadratic, which is ax squared plus bx plus c, that coefficient tells us whether it opens up or down. Okay? So here we go. The graph of a quadratic function f of x equals 3 plus 4x minus x squared intersects the y-axis of point A and has a vertex of point B. First off, before we even look at the questions, you should kind of start to evaluate the quadratic using what you know about the properties and also what you know about the forms. This form of the quadratic, out of the excuse me, out of the three that we talked about, general, factored, vertex, which form is it?
General.
It is general. It's just written how?
C.
Backwards.
It's written backwards. So it's technically C plus BX plus AX squared. You can write it the forward way, going forwards. You just want to make sure that you keep the signs with the correct terms. So that X squared is still a negative, BX is still positive, and your C is positive. So looking at that and knowing what we know about standard form, the 3 represents what?
Y.
Your Y-intercept. Always when it's in standard form. My A is a negative, so it's less than 0. So that means the parabola should have opened, which it does. Okay? So knowing this information, this point A, which is my Y-intercept, is at 3. So this point is at 0, 3. We're able to conclude all this information before we even get to the questions. Okay?
I have a question, sorry.
Yeah.
How did you know that it was at 0, 3?
Because whatever the C value is in standard form is always the Y-intercept of your quadratic.
Okay.
Now to find the coordinates of B, B represents my what?
Your maximum.
Your vertex.
It's our maximum point. It is our vertex. And in standard form, we know how to find the X coordinate of our vertex by doing what formula?
-b/2a.
Not only does this get me my axis of symmetry, but it also gives me the X coordinate of my vertex. What is the value of B for this quadratic?
4.
So it's going to be -4, because the formula is -b/2a. And what's the value of A?
Okay, I have the
Negative
email in
1.
front of me.
-1. So I have -4 over -2, which is what?
2.
Positive 2. So the X coordinate of my vertex is +2. I use -b/2a, plugged in my points, and simplified, and that's the X coordinate of my vertex. That is also my axis of symmetry. I might not need that information, but it doesn't hurt to have. Okay? How do I find the Y coordinate of my vertex?
You plug 2 into the formula. Into the original.
I plug 2 into the original for X. Okay? So I'm actually going to do F of 2. So I have a negative X squared plus 4X plus 3. I'm replacing 2 everywhere I see an X. Now this is where either your skills of operation come in or your bomb skills of using the calculator, okay? Negative parenthesis 2 squared plus 4 times 2 plus 3. Before I click enter, I want to ask you, if you were to do this by hand, what do you do first? Do I apply the negative or do I do the square first?
The square.
I do the square. So it's a 2 squared, which is,
4. -4.
so it turns into a -4. What's 4 times 2? Plus 3. So that's going to be a +4 plus 3. So my answer should be,
7.
and that's exactly how the calculator gets 7. I wanted to make sure to go over the concept of exponent first, then apply the negative, because you'll get something completely different if you try to square a -2. So there's my vertex. It is located at 2, 7.
Okay, so to be exact, so you do, to find the vertex for axis of symmetry, you do -b/2a, and then what if you get that? That represents your x value, and then you plug that into the f, and then you get your y value.
Exactly. Yes. All right. Now it says another point C, which lies in the graph of y equals f of x, has the same y coordinate as A. C is not in this picture. You have to plot and label C on your graph. Well, if C has the same y value as A, what was the y value of A? 3. So on the exact same line that A is on, C is on as well. And there's C. It lies on the same, it has the same y coordinate, which means it lies on the same y line as A does.
And to get C's x coordinate, you plug in a y for that equation.
You can. That is one way that we can find the x coordinate of C, by plugging in 3 for y and solving the equation. Another way we could do it is because since this is the axis of symmetry and it splits the parabola in half, if I can figure out how far away A is from the axis of symmetry, C is the exact same distance. So how far is A away from the axis of symmetry? 2, which means that C needs to be the exact same distance away as well. So if A's x coordinate was 0, that means that C's x coordinate needs to be 4, because that is 2 units away from the axis of symmetry. Again, we could have also found it by plugging 3 in for y and solving the quadratic using factoring or factoring skills. And here's an IB problem. Questions?
Wait, I have a question. What do you mean when you say you could have also done it like plugging 3 into y? You mean the original like negative x squared one?
Yes. So I could have done it algebraically by plugging in 3 for y and setting it equal to the quadratic and solving. To solve this, I would have subtracted over the 3 to make sure it was equal to 0. And then I could have factored using GCF this negative x squared plus 4. If I take out x, I'll get a negative x plus 4 equals 0. And then I would set both of the factors equal to 0. So I have x equals 0 and negative 4 plus x equaling 0. This value is the x coordinate of A. And then when I solve this out, this is your x coordinate of C. So it could have been done algebraically or using some inductive reasoning.
I'm sorry, but that whole brown.
We're going to find the equation of the quadratic. Now, when you're looking at the quadratic that's in this picture, and I know it's not specifically labeled, but this point right here is located where? On the x-axis, what is its value? -5, and I know it's kind of hard to see, especially since it's not labeled specifically, but yes, it is -5. And this point, +1. Those 2 points, -5 and +1, represent your what? Your x-intercepts. Very good. Okay. You also have this point down here called your what?
Vertex.
Your vertex. What is the coordinate of your vertex?
-2, -9.
So we can pull that out just by looking. And depending on the
Wouldn't that -5 right there where it crosses the y value, wouldn't that be C?
Yes, it would be. So we even know our y-intercept. That's at 0, -5. Very good.
Wait. Yeah, like you know how when you're writing the equation, the C is your y-intercept, that would be your value? How was that? Yeah.
Oh, never mind.
Yeah, so
You're talking about the other -5.
no, she's talking about this particular -5. This one right here represents your y-intercept, aka your C in general form. Now this particular graph is interesting because out of all of these 4 points, I have enough information to write my quadratic any of those 3 ways. I have my vertex, so I could start by writing it in vertex form. I have my x-intercept, so I could write it in factor form. The last way I probably would encourage you to write it would be in your general form, because even though you do have your y-intercept, you're going to have to use a system to actually find the rest of it. So if you're giving your x-intercepts or your vertex, then you are going to want to use that respective general form to write the equation of this quadratic. So do you want to use our x-intercepts or our vertex? X-intercepts. To be honest, it doesn't matter. Either way, we're still going to get the same answer. So the general equation for our x-intercept form is y equals a, x minus p, x minus q. And p and q represent your what? Be more specific. Thank you. So that means I'm going to plug them in for p and q. Doesn't matter which one goes in for p, doesn't matter which one goes in for q, as long as they both go in. So that's going to be x plus 5, because a negative 5 and a minus make a positive, and then x minus 1. Right now, I'm basically one variable away from actually writing my full equation, that variable being the a. This skill of finding a missing variable in an equation is a skill we're going to use across all of the functions. So please make sure you're paying attention because it's very important. To find a missing variable in your equation, you are going to use some other point on the graph to find the value of a. We're going to use some other point on the graph to find a. I cannot use my x-intercepts because I've already used those to start writing my equation. So that means I'm either going to need to use the vertex or the y-intercept. Doesn't matter which one I use, I'm still going to get the same answer. Which one do you want to use? I think I heard more y-intercepts over the vertex. Let's use y-intercept. So that means I'm going to plug in -5 for y and 0 for x. And I'm going to solve for a. So this becomes -5 equals a times 0 plus 5 is? 0 minus 1 is? And what's 5 times -1? So this becomes -5 equals -5a. I just moved the coefficient to the front. How do I solve for a? So a is equal to 1. So the coefficient for my quadratic, my leading coefficient is 1. So my function for this particular graph is y equals 1, which I don't really have to write because you know it's the invisible number, is this.
I noticed that whenever you're using basically C, plug in for P and Q, you switched it. So like, I think,
yeah, because in the general formula it's a minus, and so that's how we get the plus there. And then when we plug in 1, it just stays the +1. That's why when it's in this factored form, when you pull out the x-intercepts, it's the opposite of those. Same thing applies with the vertex. You know that parenthesis? If you were to plug the -2 in, it would turn into an x plus 2 if you were to do vertex. What if I wanted to change this into standard form? What would I do? I'll FOIL it out. So that's x squared plus 4x minus 5. Because it may ask you to write it in standard form, but that doesn't mean you can't go x-intercept form to get to standard form or general form. Okay? The graph of the quadratic function f of x equals c plus bx minus x squared intersects the y-axis at 0, 5 and has a vertex of 2, 9. Here's another one that's written backwards. You don't have to keep it in that backwards format. You can write it the right way. If I wrote it the right way, how would it go?
-x squared plus bx plus.
Very good. And C represents my what?
Y-intercept.
My y-intercept. I know that A is at 0, 5, and I know that B is at 2, 9. So what's my C? 5. It is the y-intercept. That's why it says write down. Anytime you see this, that means little to no work is needed. Because the problem is more than likely staring you in the face, or you just got to add like 1 and 2. Okay? Very little work, or right in front of you. Now you have to find the value of B. This could be done a couple of ways. This could be done a couple of ways.
Could you turn it, well, that's your vertex, so could you turn it into vertex form and then convert it to standard?
We have to do a lot of, we're not,
I mean, it's not too much, but like, there's probably an easier way.
now that could definitely work though. We could use the vertex form. My A's are the same across all my forms, so then I could do that and then I could distribute it out, get my B. I could definitely do that. It's another way. Remember what I said about I can find any variable in an equation by taking a point and plugging it in, right?
Yeah, so,
And I already know what C is. I just found it over here.
oh, okay, so then you could do 9 and then plug in 2 for.
Exactly. I could do this and find B this way, because again, C is 5, and I can solve it out that way. I just went over this whole negative parenthesis 2 squared thing. Do I apply the negative? Do I square it?
Square first.
Square it first, so it turns into a,
-4.
this becomes a 2B, and this stays a 5. What's -4 plus 5?
1.
Oh, I combine them. So I'm gonna subtract the 1 over instead.
And just to clarify, you put 9 as the f of x because that's y.
Exactly.
So B equals 4.
So B is equal to 4. There is another way to do this. What's your formula for the axis of symmetry? What's at the beginning of this?
And then, so there's,
So if you know the x coordinate of your vertex, you know your axis of symmetry. So I can plug in 2 for x, and then what's the value of a?
-1.
So this becomes 2 over negative b over -2, which is just a positive b over 2, and then multiply both sides by 2. You could have done it this way as well. Now to find your x-intercepts of your graph. Your x-intercepts are nothing but the points on the graph where y is equal to 0.
So set y equal to 0 and
Set y equal to 0, and then you can factor. Because if you can factor it, you'll be able to find your x-intercepts. Or if you want, you can use your calculator. Doesn't hurt. Which way? Use the calculator. If I do the calculator, I go to my y equals. I plug in that function, -x squared plus 4x plus 5 into y1. I plug 0 into y2, and I graph. And I'm looking for those 2 intersection points, which I can really easily see what they are. What's this intersection point right there?
-1.
-1.
0.
And the other one is at 5.
0.
I also do old school factoring with that as well.
Could you do it without a calculator?
Mhm.
Find it?
By factoring. You will wanna, me personally, I do not like factoring when the leading term is negative. So I like to factor it out. I'm out of space here. So me personally, I like to factor it out. So then that way I don't have to worry about it later. This also helps me not have to do the whole California method where I gotta multiply A and C and do slide, divide, bottoms up. It just makes things so much easier. What two numbers multiply to give you -5 that add together to give you 4? -4. -5 and 1. So this becomes x minus 5 and x plus 1. One other positive about doing it this way, you see how in part D I gotta write it in that form? I'm already done. So then I just set these two factors equal to 0.
I have a question. What about the negative in front?
Doesn't matter because it's a -1.
So you just put that in there.
So if I put -1 equal to 0, that's not possible.
Yeah.
So then that's out. So then that's how we get 5 and -1. So that's how we do it algebraically as well.
Wait, what do you mean you don't like factoring with the negative?
Like if I left the negative as the A term, I have to do slide, divide, bottoms up. Like I have to multiply the -1 to the +5, find your two numbers, and then divide by -1 at the end.
Oh, that's why it wasn't working.
And when you did the X method, that's yeah.
Yeah, so that negative kind of throws everything off.
I multiplied A and C, but then I forgot to bottom side.
Dang it, I hate when it does this. That's so annoying. There it goes. So now it's just asking me to write in that form. Well, I have it right there. It's right there in its factored form. Right here. So my final answer for D, which I have 0 space, y'all. And so I'm sorry if I'm going everywhere with this. I don't have the space. But I'm gonna put D right here. It's gonna be f of x equals -x
Plus minus 5.
minus 5 x plus 1. That's my answer to D.